All right, this video is to help you guys kind of get through the Predicting Products worksheet. I believe it's Predicting Products worksheet 2. This was a good practice for the exam because this is kind of how you're going to see it. The exam will only be 3 demo reactions that I'll do up at the front, and then you'll have to identify the type, write the word equation in full, and then the balanced formula equation. Okay, so we'll go through each of these. So the first one says aluminum reacts with nitrogen gas. Okay, my recommendation is to start with the formula first. So you want to start down here. So we know aluminum, and it says aluminum metal, so that means it's going to be a solid. Reacts with, you want to think of as just the plus sign, and then they give you nitrogen gas. And nitrogen gas is a Hobberfinkel. It's a diatomic element, so it's N2 in gas form. Now that's all they give you. From here, I would try to identify what type of reaction we're dealing with. Now I have a single element and a single element, so that is going to lead me to believe that this is going to be a combination synthesis. Okay. Combination synthesis, which means that these two elements are going to combine together. Okay. Now on the exam, we'll give you a clue as to whether solid, liquid, or gas would form from this, but aluminum nitride is a solid. Okay, now the question is, since you're combining them together, you do need to look at charges. We know aluminum is +3, nitrogen is -3, nitride's -3. So we actually don't have to add any subscripts on this one, okay? But we do have to balance. We have 2 nitrogens, we have 1 nitrogen. So we got to put a 2 here. And then that changed aluminum, so we have to put a 2 in the aluminum out front. Okay? And then last, I would write the word equation. So you kind of steal what's written up here. Aluminum, metal, reacts with nitrogen gas to form solid aluminum nitride. Okay, so the word to form is kind of what is represented by that arrow. Okay. All right. Moving on. Here we have iron 3 bromide is mixed with barium hydroxide. So start with the formula again. So iron 3 is iron +3. Bromide is bromine, so it's -1. So we have Fe +3, Br -1. So this formula is FeBr3, and it's mixed with barium hydroxide. Barium is +2, hydroxide is -1. Remember, hydroxide is OH, so +2 -1. So this becomes BaOH2. Okay, so from here, I'm just going to move everything down just a touch and over. What type of reaction do we have? Well, we have a compound plus a compound. So it looks very complex. It's leading me to believe that it's a double replacement. Now what happens in a double replacement is that the metals trade places. So now Ba is with Br3 and Fe is with OH2. Okay, but don't forget the charges. Bring the charges with. And then double check to see if your subscripts make sense. So if we look at BaBr3, does that 3 need to be there? No, it should actually be a 2. Okay, and if we look at FeOH2, is it a 2 that's needed? No, it's actually a 3. Okay, Now that we have that, I'm just going to erase the charges to kind of clean this up a little bit. And we want to balance the whole thing. And it's kind of on you to figure out what you want to start with. I'm going to start with the bromines. I have 2 bromines, I have 3. So anytime you have a 2 and a 3, find your least common multiple, which is 6, and then multiply by that number that's needed to get you to 6. So I put a 2 in front of the FeBr3 and a 3 in front of the BaBr2. And then now go back and balance the other things. Okay, so now you have 2 irons, so I got to put 2 irons in there. I have 3 bariums, so I got to put 3 bariums up over here. All right, and now writing the word equation, I'm going to get smarter here. Watch what I'm going to do. I'm going to, oh, sorry. I'm going to copy this and paste the image and just finish this sentence. So iron 3 bromide is mixed with barium hydroxide to produce barium bromide and iron 3 hydroxide. Now you might be saying, well, what about states of matter? In this question specifically, nothing is highlighted as to what the state of matter would be. I can tell you that they are all aqueous, except in the products. Barium bromide is still aqueous. Iron hydroxide is a solid. And you might be thinking, well, how would we know that? You wouldn't. We would provide those for you. We would clue you in. Okay? All right, we got 6 total. Let's do the next one. Sodium bromide reacts with chlorine gas. Okay, so sodium bromide is NaBr, and chlorine gas is Cl2. And it's Cl2 because it's a Haber-Finkel. It's the coal of Haber-Finkel. Now, they do tell us that this is a gas. Sodium bromide is a solid. It's a salt. Okay, if we look at this, what type of reaction do we have? We have compound with single element. So this is making me think that this is a single replacement. Okay? Now, my single element is chlorine gas, which has a -1 charge. Okay, if we look at this, we have sodium and bromine. Now the question is, what does the chlorine want to replace? Does it want to replace the sodium or the bromine? And what you got to remember is that it's always going to replace the thing that it is charged similar to. Okay, so it has a negative charge, it's going to replace the thing with the negative charge. So that's the bromine. So the chlorine replaces the bromine. Now it's NaCl plus bromine. Now bromine is a Haber-Finkel. It's the Br part of Haber-Finkel. So it's a diatomic element, so we put a Br2 in there. Okay, bromine is a gas when by itself, and NaCl we're just going to say is a solid as well. Okay, now in balancing the whole thing, we put a 2 and we put a 2. All right, the word equation. Again, I'm going to, instead of rewriting the whole thing, I'm just going to take from up here. Sodium bromide reacts with chlorine gas. The arrow means to form or to make solid sodium chloride. And the arrow in the products you can refer to as and bromine gas. Period. All right, we're moving. Number 4, cupric sulfide reacts with potassium chloride. Okay, so in looking at this cupric, I might have to do a little bit of searching here. Cupric. Sorry, we were Googling fairies. My daughter wanted to draw. All right, so cupric is copper plus 2. Okay, so that's copper plus 2. Sulfide is sulfur, which is minus 2. Potassium is plus 1. Chlorine is chloride, which is minus 1. So the balanced formula, let's start it. So we would have CuS plus KCl. And again, there's no mention of states of matter, so we're just going to go aqueous for both. Okay, and again, that'll be provided for you. We'll clue you in as to how to do that. It's plus 2 minus 2 plus 1 minus 1, so I don't have to add any subscripts. I look at this and I see compound and I see compound, so off the bat I think double replacement, which means that the metals will trade spots. So now I have KS plus CuCl. Now remember, don't forget your charges. Potassium is plus 1. Sulfur's minus 2, copper's plus 2, chlorine's minus 1. Okay, so that means I have K2S and CuCl2. Just going to erase the arrows. And now we balance the whole thing. So we put a 2 here, and that does it. Yep. We're just going to say we have aqueous solutions. We're not even going to get into solubility. Aqueous all around. Okay, the word equation. I'm just going to steal my start here. There we go, pasting. All right, so we got thus far right to here. So the arrow means we'll say to make. K2S is potassium sulfide, and cupric chloride. Now you could say copper too if you don't want to say cupric. Cupric chloride. Okay. All right, number 5. Nitrogen trihydride decomposes into its elements. So right off the bat, they give us a clue. Decomposes. So that means the type is it decomposes. So nitrogen trihydride, that's a covalent structure. It's NH3. And if it decomposes into its elements, it's N and H. That's all you got. But N and H are both Haber-Finkels. So it's N2H2. So these are both gases. And then nitrogen trihydride we're going to identify as a gas as well. So in balancing, let's start with our hydrogens. We would put a 3, and then a 2, and then, look at that. We already balanced the nitrogen. So it is balanced. In writing the word equation, I'm going to not copy it, and I'm going to give you the full word equation without the top up here. So I have gaseous nitrogen trihydride decomposes to form nitrogen gas and hydrogen gas. Now you might be wondering, well, why did you include the states of matter in this one, but not the previous one? And you know what? You're right. if we wrote this with the proper states of matter, it would be aqueous cupric sulfide reacts with aqueous potassium chloride to make aqueous potassium sulfide in cupric chloride dissolved in water. Because remember, dissolved in water means aqueous. Okay? So you're right. You're right. We do want to include the states of matter if we have them in the word equation. Okay, 6 is the last one. It says mercury 2 oxide is formed from its elements. So this is kind of an interesting one. They actually give us the product here, which is HgO. And it's formed from its elements. Well, its elements are Hg and O. But O is a Haber-Finkel, so it's got to be O2. It's a gas. Mercury is actually a liquid at room temperature, so we're going to put an L in there. Mercury 2 oxide. You know what? We're just going to say that this is a solid. How about? Okay, and maybe let's double check and see if that's true. Mercury oxide. Solid at room temperature. I guessed right. Okay. So we're good. We just have to balance this equation. So notice I have 2 oxygens. I only have 1 oxygen, so I got to put a 2 here. Now I got to balance my mercury, so I put a 2 up there. And now we're balanced. This reaction type is a combination synthesis. Okay. So this is combining to form its elements. All right, sorry, to finish, it's combination synthesis. Writing out the word equation, we would say liquid mercury is reacted with, and the reacted with is what's represented by that plus. So it is reacted with oxygen gas to form, that's what the arrow is showing, to form mercury 2 oxide. Solid mercury 2 oxide. All right, and that takes us to the end. Hope this helps. Email me with